Dear students, in this video now we are going to continue with the another resistance welding techniques, that is the seam welding, projection welding and percussion welding. So we have seen the spot welding. Okay, also we have seen the limitation of spot welding. The limitation of spot welding is what? So the shunting of electricity. Okay, I will discuss now. The shunting of electricity in the spot welding is very high. What is mean by shunting? That is the bypassing of the electricity or current, bypass of the current through the constant or continuous media, that is the shunting. So what happening actually in the spot welding? See, so if this is the spot, suppose you have required around here the current of say 10,000 amperage. Okay, you require the current of 10,000 ampere. Of course this is power supply. Okay, so here now when we go for the next spot, then again for this spot also we are requiring say 10,000 ampere current. But what happened, because of this shunting of the electricity, the current is trying to pass through the continuous media. Okay, and the actual current they required or get here at this second spot is lesser than the required current for that spot. So around say if 10,000 is required here, so you are having the bypass of current of say 3000 ampere, because this tendency of the current to pass through this continuous medium, you will not getting exact this amount to the second spot. That is known as the shunting of electricity. So to minimize the shunting of current in the spot welding, what we are doing? We are keeping the optimum distance between the two spots so that this bypassing of the current can be eliminated. So here what we are doing? So here please remember that the distance between the two spots is how much? We are keeping it as 48 times thickness of the sheet. 48 times thickness of the sheet is actually the spacing between the two electrodes. Okay, so 48 times T is the distance between or the spacing between the two spots. Then only we can have the elimination of this shunting of electricity or shunting of current. Okay, that is the thing only. So please remember, what is the minimum distance between the two spots? It should be 48 times T. Now we will move towards the next resistance welding process, that is after spot welding we are having the seam welding, resistance seam welding. So what is there? There are two thick electrodes which are disc shape, and we are producing the partially spot welds. Okay, which are partially produced spot welds. You can also call it as, this is say flow of current, power supply. Okay, so what is seam welding? Seam welding is nothing but the continuous spot welding. Continuous spot welding is nothing but the seam welding. Continuous spot welding is nothing but the seam welding. See here, you can see the spots, number of spots which are overlapped over each other to have the entire joint. And this is what the disc shape copper electrodes which are rolling continuously, and we are producing the continuous spots, nothing but this is the seam. Okay, this is the seam welding. So this is the thicker disc shape copper electrodes used for this seam welding operation, whereas in spot welding the electrode shape was a cylindrical electrode, isn't it? Now here the main important thing is that here in seam welding you can have the shunting of electricity. In the spot welding we have seen there. So here now the spots spacing is very less, isn't it? So of course there will be the huge shunting of electricity is possible in case of the seam welding. So here what we are doing, so in the seam welding we are not applying the whatever the amount of current at a single time. So here what we are doing, so we are here slowly go on increasing the current conditions, so that what happened, up to distance of 48 times T, we are slowly go on increasing the current conditions unless the length of this seam is getting 48 times T. So whatever the shunting is going to happen will finish, and then we are applying the required amount of current. Okay, so what happened, so after I reach here 48 times thickness length, so now the starting point is so far from this point, and till then the shunting of electricity is already removed, and now you can have the required amount of current, isn't it? So in that way the shunting of electricity is eliminated in the seam welding. Okay, if you look at the applications, we have seen the advantages and disadvantages of this resistance welding, but here we are going to see what are the applications of the spot and seam welding. Okay, so basically this spot and seam welding is used for the having of the leak proof joints, okay, in the boilers, okay, then in the condensers. Then the main application of this seam and the spot welding, where without increasing the weight of the part you want to join the plates or surfaces, say for example in the aircrafts, in the bicycles, in the space shuttles. So this is very useful one. Now see, let us discuss some applications of this resistance welding. So in the applications, application number 1 we can have in the joining for the leak proof joints, whenever the leak proof joints are required in case of the pressure vessels or in case of the boilers. So this is very useful. Then again to attach, to join the fuel tanks to the automobile bodies, we can use this resistance welding. Again, the second application we can have where without increasing the weight, if you want the joint, say for in the case of aircrafts, in the case of bicycles or in the space shuttles. So this welding technique is very useful one. Again, if we talk about the joining of the tip of the tool, throwaway tip of the tool to the body of the tool, again we can use this spot welding technique. So these are certain applications of the resistance welding in that spot or seam is covered there. Now the next process that we are going to have after seam welding, we will see the projection welding. So basically this projection welding is the variation of the spot welding, where this technique is used to join the projection component on the flat component or on the flat surface. Say for example, we have to attach the bolt with the automobile say body. So this is kind of projection. So whenever the projection part we are going to attach onto the flat surface, we are using this projection welding technique. And of course, please remember that this is the variation of spot welding, which is or where the projectioned part is going to attach on flat surface. Okay, say for example, I am having this part, this is the projection. So these two parts are kept in this flat copper electrode. This is the electrode. Okay, like spot welding only. These are the flat electrodes, and this is our part. This is the projection part. Which is going to attach onto this flat plate. Okay, so here see, after this spot welding, because it's a kind of spot welding only, we will get the joint part like this. And here we are getting these spots. So this projection part is going to melt and form a joint with the flat surface. Okay, so simple. This is the projection welding. And please see, remember that here no any kind of machining or surface finishing required for that spots. It is flat totally, okay, and having good surface finish. So this is the projection welding. Projection welding. And the next welding that we are going to see, that is percussion welding. This is the fourth, percussion. This is the percussion welding. So here the two parts which are going to join are placed in this position, and there are the connectors for heating it. Okay, so this is power supply, are placed in front of one another or at the edges. And now what we are going to do, we are heating these parts or plates just below the melting point temperature of these materials. Okay, then what we are going to do here, so once the temperature reaches just below the melting point of the plates, we are going to put the pressure on it. Okay, so that what will happen, when these plates are stick together to each other, the joint is going to form at these edges. Okay, and at the same time, because material is just below solidus, isn't it? So here during the joint formation, the flash is coming out. This is the flash that can be trimmed out afterwards. Okay, so this is the percussion welding. Why percussion? Percussion means suddenly. percussively means suddenly, achanak se. So here what the process is, the plates are heating by the connector just below the melting point temperature of the plates, and now we are applying the force or pressure suddenly or percussively, so that the joint is going to form at these edges. Okay, and of course in this percussion welding, the flash is coming out, which can be uh, trimmed out. Okay, so that there is no any issue. So actually this flash is generated in this welding technique, and see, these plates are kept in the butt joint position, isn't it? This is a butt joint. So that is why the name of this welding is also we can have as the flash butt welding. The flash butt welding, because flash is going to produce in this technique, and these plates are placed in the butt position. That is why this is a flash butt welding also. So this is about the percussion welding. So in this way, students, we have seen the various types of the resistance welding, so called it as the spot welding. We have seen the seam welding, then the projection welding, and the percussion welding or flash butt welding. Thank you.